We are going to start our demo by looking at the Openshift Dashboard for the Montreal cluster. And what we see is that there is only one pod running. It's a database. So the cluster is virtually empty. Same thing with the deployments. We see one deployment, and that's the same database. We now shift over to an experimental GUI for the Kubernetes plugin of the ONAP project. ONAP is running in a different data center in University of New Hampshire Interoperability Lab, and the two data centers are connected over SD-WAN. We are going to start the demo by adding a cluster to ONAP. Basically, we're registering the OpenShift cluster. We're going to call it MTL Lab, and we are going to import a settings file to make sure that the OpenShift cluster gets registered properly with ONAP. We'll give it a label, MTL_lab. And next, we are going to create a composite app. A composite app is nothing but an application with several applications underneath it. We're going to call it ngc_mtl. There's a previously created composite app, just ignore that. Now we are going to create an application underneath that composite app. In our case, there's only a one-to-one association. The composite app consists of one application, that's the 5G core. We are going to import the package for the 5G core, which is essentially a Helm package. And now we are going to create placement intent. The orchestration is intent-based. And once we have created the generic placement intent, we can create the specific intent for the application underneath. In this case, we are creating an intent for the 5G core. Now that we have created the service or the composite app, we can deploy it. And this next step is exactly that. We are going to deploy the composite app. So we are creating a deployment intent group. And next, we are going to create a specific intent for the 5G core, where we are going to deploy it onto the cluster with the label that we had previously created. Okay, great. So we've deployed the 5G core. And we go back to the Openshift dashboard. And what we see now is instead of one pod, there are 32 pods there, including all the 5G core services. So the 5G core has come up successfully. As you know, the UPF is a PNF, and this shows you the Coloom management interface. In addition to the UPF, it shows the entire software-driven fabric. You can see the different interfaces, N3, N4, and 6, as defined by 3GPP. And you can see the UPF connected via a set of network elements. In this dashboard, we see more details. We see details of the N3 interface that connects the RAN to the UPF. Now we are going to do end-to-end testing. This is a GUI for a UE and GNodeB emulator test tool. It's called ABot. Now we have another instance of the 5G core running in the UNH lab, and we are actually going to do the testing against that. We are going to run only two tests today. The first test is UE connection request. So that test is running right now, as you see, and it passed successfully. The next test we are going to run is a UE session establishment. So now this test is running, and it's so far running successfully. We are going to see the overall results, 46 tests passed, none failed. And last but not the least, we are going to see a ladder diagram of all the different interactions between the GNodeB and the different CNFs that happened and how things passed successfully.
Now we are going to run the same use case of the 5G in a load condition. First, we are going to run it onto a hardware with a little lower configuration. We'll notice some of the uplink, downlink transactions, and we'll see that this particular test case, some of the call flows passed and some failed because of protocol inactivity. We'll look at the configuration, and then what we try and do is look at some of the internals of the failures. We'll see some of the call flows have passed, some of them have not been executed because of the limitation on the hardware. That becomes clear from the KPIs that we are looking at in terms of infrastructure KPIs and also some of the mobility KPIs, memory, disk, CPU, how much have we used in terms of connection speed and all that. Based on all this information, we are seeing there is infrastructure limitation. Now we are going to rerun the same test case on a higher configuration, which has been done through a closed loop situation. And in this time, we will see that the same call flow is now running and everything have passed. And when we take a look at some of the messages, we are seeing this time we have tried 1,000 UVs as opposed to 100 in last time. But all the messages and the PCAPs are better. The KPIs are much better than the last time. The infrastructure KPIs that we look at, we'll see as opposed to the last time, which were in reds and yellows. Most of them are in green. They are within the correct zone to show that we can reconfigure and get better results. Thank you very much.